So what we are doing is R2 changes to minus R2. So first row remains the same. 1, 1, 2. Second row we have to multiply with a negative number. Means negative 1. So 0. It will become 2, 5. Third row remains the same. 0, 1, 3. And on the right side first row is the same. Minus 2, 1, 0. Second row we have to change the negative. So 5 will become negative 5. Minus 2 will become 2 and 0 is the same. Third row is the same. 0, 0, 1 into A. Again what we have to do, we have to make the second row, second element as 1. We can take 2 outside, but we will get a fraction 5 by 2 here, here minus 5 by 2 and here 1. So the next step we have to do with the addition and subtraction with the fraction. So it is better to avoid taking 2 outside. Other than that, 2 minus 1 will give you 1. That means R2 minus R1 will give you 1. But if you do that, what happens is this 0 becomes 0 minus 1, which is minus 1. I already told in the previous question that whenever we change one number to 1, 0 and 0, the next operation or next transformation must not change those numbers which I have kept as 1, 0 and 0. So if I am doing the operation R2 minus R1, this 0 becomes minus 1. Okay, so we are not able to proceed with the step R2 minus R1. Again, if I am taking R2 changes to R2 minus R3, then what happens? 2 minus 1 become 1. Here also 0 minus 0 becomes no problem, it is 0 itself. So the next step what we are going to do is we are going to change R2 as R2 minus R3. So the first row remains the same 1, 1, 2. Third row remains the same 0, 1, 3. And on the right side also first row minus 2, 1, 0 remains the same. Third row 0, 0, 1 also remains the same. Instead of the second row, here R2 minus R3, 0 minus 0, 0. 2 minus 1, 1. 5 minus 3, 2. Okay, and on the right side minus 5 minus 0, which is minus 5. 2 minus 0, 2. And 0 minus 1 minus 1. So we are getting the matrix like this. So we got the second row, second element as 1. Again what we have to do, we have to make these two 1, 0. So easy. It is very easy. R1 changes to R1 minus R2 and R3 changes to R3 minus R2. So which row remains the same? Second row 0, 1, 2. Here also second row remains the same, minus 5, 2, minus 1 into A. R1 minus R2, 1 minus 0 is 1, 1 minus 1, 0, 2 minus 2, 0. And here 0 minus 0, 0, 1 minus 1, 0, 3 minus 2, 1. And again on the right side, minus 2 minus minus 5, that is minus 2 plus 5, which gives you 3. 1 minus 2 is minus 1, 0 minus minus 1 is 0 plus 1, which is 1. Again 0 minus minus 5 is 5, 0 minus 2 is minus 2 and 1 minus minus 1 is 2. Okay, again what we have to do is we have to make the third row, third element as 1. It's already 1. So again the next step is we have to make all the elements in that column as 0. So here it is already 0. So at the last step is we have to make this 2 to 0. What we can do? R2. This 2 is in the second row. So R2 changes to R2 minus 2R1. So which row remains the same? First row 1, 0, 0 remains the same. 0, 0, 1. Third row also remains the same on the both sides. 3 minus 1. First row remains the same. Last row 5 minus 2, 2 remains the same into A. R2 minus 2R1. This 0 will not change. Again 1 minus 2 into 0. There also no change. It is 1. 2 minus 2 into 1 gives you 0. On the right side minus 5 minus, you can calculate minus 5 minus 2 into 5, that is minus 5 minus 10, which is minus 15. Again the second value 2 minus 2 into minus 2. 2 minus 2 into minus 2. So 2 plus 4, which gives you 6. And the last element minus 1 minus 2 into 2. So minus 2 into 2 give you minus 4. Minus 4 minus 1 will give you minus 5. So we got the left side as the identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. And the matrix together with A on the right side will be the inverse. Therefore, A inverse is equal to first row 3 minus 1, 1. Second row minus 15, 6 minus 5. And the third row 5 minus 2, 2.